Hello, everyone. This is Professor Vishal Gupta with BUAD425, Data Analysis for Decision Making. This video is on fitting decision trees to the loan dataset using JUMP, and it's meant to supplement our earlier lecture. So let's get started. First thing I'm going to do is I'm going to go to JUMP. And again, JUMP opens many windows, not all of which I need, but I'm going to go to File, Open. And you'll find on Blackboard that there is a loans_clean.jmp file for you to download. This is different than the loans_clean.csv file. So please be sure that you're downloading the JMP file. We can open that up. You'll see it looks rather like an Excel spreadsheet. If you had used this JMP file to do the logistic regression portion class, for example, you may have some extra columns here. That's okay. I'm just going to go through and make sure that this first column is named default. And second, it's very important that I have these note smoking signs along the way for the first 3,000-ish rows of the data set. All right, so to fit a decision tree classifier, I'm going to go to Analyze, Modeling. Notice this is different than Fit Model, and then Partition. I'll see if pop-up window, sort of like this. I can place default into the Y's because that's what I want to predict. And then I'll use all the variables I want to use to predict this chance of default into the X's. If you have extra variables here from your logistic regression, be sure not to select them. Just pick the ones that you want to use for prediction. I can place those in there. I'm going to make sure that the method says decision tree. And then I'll hit OK. And you'll see that JUMP brings up this window that has the root stub of our tree. Because we had omitted about 3,000-ish variables for our testing set, there's only about 6,700 variables left. Now, by default, JUMP doesn't show you everything it needs to for you to do a good fitting. So I'm going to go here to this red arrow, select the red arrow, and under Display Options, I'm going to pick Show Split Probability. Now you can hide or show some of these things if you want to. I highly recommend at least seeing Show Split Probability. Okay, and you can see that now, in addition to showing us what it before, it shows us that of these 6,700 counts, about 16% of them were defaults, and about 84% of them were pays. Okay, if I want to split, start building my tree, I can hit Split, and JUMP will go off and do one split for me, and it decides that the best split it can do is on credit policy. I can hit Split again, and JUMP will decide the second best split it can do after it splits on credit policy is to split this second node into two pieces. As we talked about in class, it's not immediately obvious how many times I should pick split. The more I pick it, the more the accuracy will go up, but there is a problem of overfitting, and we'll talk more about this problem in our next session. But for now, the easiest thing to kind of do is to hit Go, and then JUMP will go off and fit a tree itself. You can see the tree as fits is pretty big. And it decides the size of this tree and where to do it based on some internal metrics that we'll learn on last time to try and reduce the chances of overfitting. Some things I want to show everyone is that there are two sides to this tree. Let's see if I can make it a bit smaller. There are two sides to this tree. The questions it asks on each side might be different. So for example, here it asks about the FICO score, whereas here on the side it's asking about the inquiries in the last 6 months. And it may ask about something more than once. So for example, here it asks about the FICO score, and if I continue down further in the tree, it asks about the FICO score again, but at a higher threshold of 762. Okay, so how can I use this tree to classify someone? Well, again, if I have a new applicant, he's going to start into the top of the tree. I'm going to ask yes or no questions based on these things. So is the credit policy 1 or not? And I'll continue down, and by the end of the time, I should end up in one of these leaves. Now, if I look at the leaves, I can see for each one, they tell me the probability that someone who will arrive in this leaf is away default. For example, if I ask that sequence of questions, and at the end of the day, I ended up in this leaf for my applicant, I know that that applicant this tree predicts that that applicant would have a 17.5% chance of defaulting. If, on the other hand, I asked a sequence of yes or no questions, and at the end of the day I ended up here, this tree predicts that this applicant would have only a 1% chance of defaulting. Okay, great. So we'd sort of like to go through our data set and label each of those people with the chances that they would default. I can do that just as I did for logistic regression by going to this red arrow, going to save columns, and I'm going to put in save prediction formula. Some students get confused. Should I write save predicted or save prediction formula? I always remind them that predicted is not a word, so probably you should pick save prediction formula. You pick that one, and then I go back to my jump spreadsheet. You'll see that it's added some columns for me. So most importantly, here's the probability according to the tree model that this person defaults. So the first person has a 15% chance of defaulting, while the fifth person has a 4.8% chance of defaulting. Here, of course, is the probability that they paid. And if I move a little bit further along, we have this last column, which again is, I do not think is super helpful, but is Jump's prediction of what that person will do. And what Jump does is it simply compares this probability to 50%. And if it's above 50%, the Jump predicts the person will default. For a problem like ours with very asymmetric costs, we talked about in class that this is a bad idea. We should probably use a different threshold. So how can we use a different threshold? There is a way to do it in Jump. It's a little bit kludgy. So instead, I usually recommend to students to save this to Excel and do it. How do I save to Excel? Again, I can go to File, Save, Export on a Mac. And on Windows, it's going to be File, Save As. On a Mac, you hit Export and choose Excel. On Windows, you're going to change the file type from JMP to Excel Workbook. I'll hit Next. Pick to save it something. So let's say loans, clean video tree. I'll save it down. And then I can fire up Excel. I'll open up this Excel spreadsheet I just created. And you can see we have all of our data points, and in addition, this probability of default for each person according to that tree. How will I do my classifications now? Because again, I don't like this column, so let me delete it. Well, now I'm just going to pick a probability threshold, much like I did in linear regression. Much like I did in logistic regression. So in this case, maybe I'll say anyone who has more than a 5% chance of defaulting is someone I believe will default. And I can do that then and say my tree predictions, I'll write as if probability of default is greater than 5%. Then I predict that this person will default, else I predict they will pay. I can send that all the way down, and that's my series of predictions. Now, why 5% and not 3% or 10%? Again, the only way to sort of pick a good threshold here is to now form the confusion matrix for these tree predictions, and then compute something like the profit or the number of loans given out to try to understand what is a good threshold for something that relates to our business. I won't do that in this video. There are other videos teaching you how to make a confusion matrix. One last thing, unlike logistic regression, I have to use a probability threshold to use these trees. There is no notion of a score with a tree. So I can't convert this probability threshold to a score or anything like that. I should only just think about it as a probability threshold. Similarly, it's sometimes for certain questions, if we're looking directly at the tree, you can look at each node and decide for a threshold of 5%, would they pay or default? So for example, for this leaf, at a threshold of 5%, we would say that this person pays, this person defaults, this person defaults, this person defaults, this person defaults, this person pays, this person defaults, and this person defaults. And in each case, I'm just looking at this probability, see if the probability of default exceeds my threshold of 5%. Okay, that's all there is to fitting decision trees using JUMP. We'll get some more practice in class. If you have any questions, please check your notes, watch some of the other videos, and bring your questions to class or to office hours. Thank you so much.